Yeah, hi everyone, welcome to PrepFusion. So we have been studying about limit, continuity and differentiability. So that particular part is completed. Now there is very small part. There is this very small topic. The name is mean value theorem. Lagrange's mean value theorem. In short, we will call it LMVT. So usually whenever I teach you any theorem, we have studied sandwich theorem or any kind of theorem, there I used to say that you don't need to remember the name, right? You don't need to remember the name and you just need to solve the problems. Treat it as a statement and solve the problem. But for the very first time, I am asking you to remember the name here. What is the name of the theorem? Lagrange's mean value theorem. You need to remember the name because in the examination, what kind of question will be asked? They will write down, find the value of C satisfying Lagrange's mean value theorem for fx equals to this. That means they will not give you the statement. By default, you should know what is LMVT. Are you able to understand this point? So you need to remember the name as well. What is the condition? The condition is that there is a function fx which is continuous in the closed interval a to b. Closed interval a to b means, what is the meaning of this? Sir, f of a plus should be equals to f of a, sir. F of b minus should be equals to f of b, sir. And function should be continuous for all x belonging to open interval a to b. Do you understand this thing? Absolutely, sir. What is the meaning of differentiability in the open interval? You don't need to care about, no care about f of a, f dash of a and f dash of b, right? Understandable, right? What is the meaning of differentiable in the open interval? That means it should be differentiable at all the points between a to b, but we will not care about f dash a plus or f dash b minus. Although b minus will be belonging to this interval, although a plus will be belonging to this interval, but we will not care about them. This we have already studied. So now what is the condition they have given? Let's just say this is our graph of fx versus fx. Fx is a function of x. So I am drawing the graph of fx versus x. So this is your point x equals to a. This is your point x equals to a, and this is your point x equals to b. Okay. This is your point x equals to b. So at x equals to a, the value they are giving is f of a. At x equals to a, the value the function is giving is f of a. And at x equals to b, the value the function is giving is f of b. Now the function should be continuous. Between a to b, the function should be continuous. Okay. And along with that, it should be differentiable as well. So can I make a function like this? This is the function that I have made. Between a to b, the function is going like this. Is that clear to you? So now what they are saying, you join these 2 points. Which 2 points do you join? You join these 2 points. When you join these 2 points, what will be the slope of this line? What will be the slope of this line? Sir, at y-axis, what is the value? F of b. And then, sir, what is this value? F of a. Divided by x-axis value, b minus a. This is the slope, right? What is the slope of this line? What is the slope of this line that I have drawn? What is the slope of this line? At x equals to b, the value is f of b. At x equals to a, the value is f of a. Now, what will be the slope of this line? If I draw a line, I want you to find out the slope. So, what you will do? Sir, at y-axis, what is the value? Let us say the value is 4. Here the value is 2. Here the value is 1. And here the value is 3. So, what you will say? Sir, 4 minus 2 divided by 3 minus 1. So, slope will come out to be 2 divided by 2. Slope is 1. So, similar thing I had done. What is the slope of this line? F of b minus f of a divided by b minus a. The slope I have find out. Okay. Now, on this curve, there will be at least one point. There will be at least one point, and on that particular point, if I draw on that particular point, if I draw a tangent on that particular point, if I draw a tangent, then that tangent will be parallel to this line. Isn't it this tangent parallel to this line? And if two parallel lines are there, if I am saying that this line is there and this line is there and both of the lines are parallel, if the slope of this line is m, then what will be the slope of this line? This will also be m only, no? Because they will be making the same angle. If they are making the same angle, that means their tan theta will also be same. So two parallel lines will have the same slope. So what I did was there were two points. The graph was like this. Between a to b, my function is continuous and differentiable, and it is continuous at x equals to a, at x equals to b. Then what I did was I joined these 2 points and I calculated the slope. When I joined these 2 points, I calculated the slope. The slope came out to be f of b minus f of a divided by b minus a. Now on this curve, if I take some point and draw the slope on that particular point, then what will happen is that the slope of this, what will be the slope of this point? what will be the slope of this point, or I should say what will be the tangent on this point? So that would be nothing but f dash, and I am taking this point to be C. I am calling this point to be nothing but C. This point is nothing but x equals to C. This point is nothing but x equals to C. Okay. This point is nothing but x equals to C. So what will be the tangent on this point? Sir, that will be nothing but f dash C, and that would be equals to f of b minus f of a divided by b minus a. Did you understand this point or not? Why they will be equal? Because they are having the parallel lines. Both of the lines are parallel. This line is parallel to this line. Both lines are parallel. If both lines are parallel, that means they will have the same slope. So what I did was I drew a curve. It was continuous and differentiable between a to b, and it was continuous at a and b. Then between a and b, there will be one point C. This C will be between a and b. This C is between a and b. So there will be one point C such that if you draw the tangent on this particular curve at x equals to C, that means if I am drawing the tangent on this curve at x equals to C, that will come out to be equals to f of b minus f of a divided by b minus a. That means both of the lines will be parallel and they will be having the same slope. Is that clear to you or not? Okay, so this is the statement of Lagrange's mean value theorem. Now sir, here at least word is written. Why they have written at least? Why at least? Because sir, the scenario could be like this as well. Let's just say this is the scenario. So what is the scenario here? This value is f of b and this value is f of a. This point is x equals to a and this point is x equals to b. Understandable? This is x equals to a, x equals to b, f of a, f of b. You need to join these 2 points. You need to join these 2 points. And when I join these 2 points, what is the slope I will be getting? What will be the slope of this line? When I join these 2 points, so the slope of this line is coming out to be f of b minus f of a, y-axis minus y-axis divided by x-axis minus x-axis. So this is the slope of this particular line, right? This is the slope of this particular line. Now on this curve, I need to choose 2 points. Let us say this point is C1 and this point is C2. So on these 2 points, if I draw the curve, if I draw the tangent, what I will see is that in these 2 points, if I am drawing the tangent, I can see that this tangent is also coming parallel, right? This tangent is also coming parallel and this tangent is also coming parallel. So let's just say this particular point was C1. This particular point was C1 and this particular point was C2, right? This was C1 and this was C2. So what you will say here? So f dash C1 would be equals to f dash C2. Why is that so? Because the slopes are same, no? They will be making the same angle. All are parallel lines, so they will be making the same angle. That means their slope will be same, and that is equals to f of b minus f of a divided by b minus a. So that's why at least 1 point is written. Okay, at least 1 point is written. Why is that so? Why this at least word is written? Because sir, there could be more than 1 point as well between a to b. Always remember, this is very important. Between a to b. Why you did not write down c belonging to closed interval? That means c could have the value of a as well. No, it is not differentiable here. No, you cannot comment that sir, f dash a would be finite. No one is commenting that. Why is that so? Because I am saying that it is differentiable in the open interval. Since I am saying open interval, that means I cannot comment what will be the differentiation value at x equals to a, what will be the differentiation value at x equals to b. So I am only caring about the points in between. Is that clear to you? But the graph should be continuous. Why graph should be continuous? Because here I am writing down f of b, f of a. So if graph is continuous, then only you can define f of b and f of a. No, if I am saying that graph is continuous, f dash a, f of a plus is equals to f of a and f of b minus is equals to f of b, that means they are finite. They are finite. And in the theorem, when I am writing down the expression, I need this value. No, f of b value I need, f of a value I need, b value I need, a value I need. That means they have to be finite. And f dash c also has to be finite because the value of c I need. But do I need f dash a value? No. Do I need f dash b value? No. So that's why there is this open interval. Is that understandable to you? So did you understand the meaning of Lagrange's mean value theorem? That's why 2 points you need to pick: x equals to a, x equals to b. Find out the value f of a, f of b. Draw the curve in between. There will be 1 point such that if you draw the line joining a to b, what will be your slope? F of b minus f of a divided by b minus a. On the curve, there will be 1 point such that its slope will be same as f of b minus f of a divided by b minus a. So the slope on that particular point or tangent on that particular point could be known as f dash c. Similarly, sir, there will be at least one point like that. There could be 2 points as well. So f dash c1 will be equals to f dash c2 equals to f of b minus f of a divided by b minus a. What kind of question are asked, sir? This kind of questions are asked. That you need to find out the value of c satisfying Lagrange's mean value theorem for the closed interval 1, 2, 3. So what is the first task that you need to do? First task is that you need to check the continuity. What is the first task? That is it continuous in interval? Is it continuous for all x belonging to closed interval 1, 2, 3? So this is your fx. Is it continuous? Is it continuous? Absolutely. You can check the continuity, no? Basically, is it continuous or not? Do you know the graph of under root x? Yes, sir. This is the graph of under root x. This is under root x minus 1. That's it. Nothing else. Right? Under root x minus 1. So at x equals to 1, it will give the value 0. So the graph will go like this. Is it continuous? Let me draw the graph. Can you draw the graph of under root x minus 1? At x equals to 1, the value will be 0. And I only care about the graph between 1 to 3 only. Right? So f of x versus x I am drawing. Only I care about values between 1 to 3. Nothing else. So at x equals to 1, what will be the value it will be giving? 0. At x equals to 1, I will be getting value 0. At x equals to 3, what value I will be getting? Under root 2. So how the graph would go? This is how the graph would go. This is how the graph would go. That's it. At x equals to 3, the value is under root 2. So is it differentiable between all the points? Absolutely. Is it continuous? Yes. So continuous and differentiability. Someone would say that, sir, can I comment on the differentiability at x equals to 1? No. Can I comment on the differentiability at x equals to 3? No. You don't even need to, right? Because you need to tell the differentiability in the open interval. So is there any sharp change? If the graph was like this, let's just say if the graph was like this. If the graph was like this, then what would have been your answer? That, sir, it is not even differentiable at this point. That means you cannot apply Lagrange's mean value theorem. Theorem cannot be applied. This will be your answer. But it is continuous as well. It will be differentiable as well. Job done. Right? Job done. That means there will be one point C here. If you join these 2 points, which 2 points? If you join these 2 points, then what will be the slope you will be getting? The slope that you will be getting. Then on this curve, if I take one more point, on this curve, when I am taking one more point and I draw the slope here, then both of the slope will be same. So that point is nothing but some point C. I am taking that point as nothing but some point C. So continuity is checked and differentiability is also checked. Differentiable for all x belonging to 1, 2, 3. So that is also checked. So now what I need to do? F dash C would be equals to f of b minus f of a, f of 3 minus f of 1 divided by 3 minus 1. So here the value is under root 2 minus 0 divided by 2. What is the answer you are getting? 1 by under root 2. And now what is the value of f dash c? Sir, value of f dash x. From here, what is the value of f dash x? So value of f dash x is 1 by 2 under root x minus 1. So in place of x, you put c. So what will be the answer you will be getting? 1 by 2 under root. In place of x, you need to put c. C minus 1. So that will come out to be 1 by under root 2. So what is the value of c you are getting here? So that is coming out to be this under root 2 will become 1. So 2c minus 1. C is coming out to be 2c minus 2. क्या हो रहा है भाई? कैलकुलेशन नहीं होती यार एक तो मेरे से. 2c minus 2. I am not able to do this calculation now. F of 3 value I have put correctly. Yes, under root 2 divided by 2. Everything is correct. 1 by 2 under root 2. This calculation is also correct. So now under root 2, this will get cancelled out. You are getting under root 2c minus 1 equals to 1. Right? So value of c is coming out to be 3 by 2. So, sir, this is the answer. Blindly you should not say, sir, this is the answer. Why is that so? Because you need to check if this c is lying between 1 to 3 or not. So yes, sir, 3 by 2 is lying between 1 to 3. Then you would say that, sir, this is the answer. So at 3 by 2, at c equals to 3 by 2, at this particular point, if you draw the slope, then you would get to know that this slope is coming out to be same as this particular slope. And what is the slope we are talking about? We are talking about the slope of joining these 2 points. When I join these 2 points, what is the slope I am getting? That will be f of b minus f of a divided by b minus a. So on a curve, I will take a point C such that the slope is coming out to be the same here. Okay, so that C point I needed to find out. That C point is nothing but C equals to 3 by 2. That's it. Job done. This is the question that is done. In the examination, options will be mentioned. Option A, 3 by 2. Option B, 5 by 2. Option C cannot be determined. Option D, some other value. Okay, so always take care of this thing. Now next question we need to solve. Find the value of C for which the conclusion of Lagrange's mean value theorem holds for the function this and that. Okay, so fx equals to ln x. Without drawing the graph, we will do it now. Without drawing the graph. So first of all, I need to think ln x between 1 to 3. Is it continuous? Ln x graph we already know. So we already know the graph, although we need to check the differentiability and continuity. So you know that, sir, yes, here 1 and 3. It will be differentiable as well, it will be continuous as well. So check the continuity and differentiability. Yes, sir, it is continuous as well and it is differentiable as well. Because this is the first condition. No, if these conditions are not even followed, then there is no meaning of this theorem. So first I need to follow the condition that it is continuous for closed interval and it is differentiable for open interval. So yes, sir, it is done. Then without drawing the graph, how would I solve it, sir? There will be some point C such that f of b minus f of a divided by b minus a, sir. So ln 3 minus ln 1 divided by 3 minus 1. And what is the value of f dash x? You know that from here f dash x is nothing but, sir, 1 by x only. What is the differentiation of ln x? That is 1 by x. So this will become 1 by c. So 1 by c is equals to ln 3. What is the value of ln 1? ln 1 is 0 only. And 3 minus 2 equals to 2. So value of c is coming out to be 2 by ln 3. That's it. This is the answer. 2 by ln 3. This is the answer. Or they can give the answer as c equals to 2 log base 3e. Right? This is written as 2 log base e3. So if this goes upward, then log base 3e it would become. Okay. So this is the answer they can give in the examination hall. That's the answer. By the graph, if we need to check, we can surely. Okay. This is not the answer. We need to check one more thing. If we solve it, then what is the answer we are getting? Because I need to check that whatever the point that I am getting, this C has to be between 1 to 3 only. Right? So I need to check the value. (1.82) we are getting. 1.82 we are getting. So this 1.82 is between, this 1.82 has to be between 1 to 3. Yes, if it is there in between, then yes, it is correct. This is the answer. Okay, so always check if the value is belonging to the interval or not. Okay, so now if I draw the graph, then how the graph would look like. Now I am doing it with respect to the graph, but in the examination without drawing the graph as well, you can tell the answer. So ln x graph I already know. I know the graph of ln x. I already know the graph, but my matter of concern is between 1 to 3 only. This is the graph, but this is not my matter of concern. My matter of concern is at x equals to 1, the value is 0. At x equals to 3, the value is ln 3. At x equals to 3, the value is ln 3. So this is the scenario, right? This is the scenario. So this is the slope, this slope that you have written, and now on the curve you need to take some point. Let's just say this point I am taking, and here if I am drawing the slope on this curve, if I am drawing the slope here, then I would get to know that both of the slopes are same, and that point C I need to find out. So with respect to x-axis, what will be that point C? So that point C I need to find out, and that point C came out to be what it came out to be, that we already know. Okay, so this point C came out to be 1.82. So this point is 1.82 and this point is 3. So this point C came out to be 1.82. So between 1 to 3, it is continuous, differentiable. So yes, there is some point available such that the slope on this particular point is same as the slope of this line. Understandable? Let's go to the next question. Try solving this question. It is a MSQ based question. Okay, it is a MSQ based question. When you do the differentiation and factorization might be a bit difficult. Okay, factorization might be a bit difficult, but you can take the help of the options. What I mean to say is that you try solving this question first. You try solving this question. Here they have given is that, here they have given that f of 0 is equal to f of 4. When you put f of 4 here, you will get to know that the value is coming out to be 0 only. Okay, when you put x equals to 0, the value is 0 only. So this they have given. Okay, so they have given more than enough things. Do I need to draw the graph? No, I just need to check will it be differentiable and continuous? Absolutely. Why is that so? Because it is a polynomial. Since it is a polynomial, so polynomial is always continuous and differentiable. Polynomial is always continuous and differentiable for all x belonging to R. So it will be always continuous and differentiable. So yes, I can apply the theorem. What does the theorem says? That differentiation at a particular point would be equals to the f of b minus f of a divided by b minus a. So what will be the slope of this line? So that is 0 minus 0 divided by 4 minus 0 equals to 0 only. Basically the scenario is that if f of a is equals to f of b, if this is your f of a, okay, this is your f of a and this is your f of b, this is your f of b, this is your x equals to a. At x equals to a, the value you are getting is f of a. At x equals to b, the value you are getting is f of b, and both are same. Then what will be the slope of this line? The slope of this line has to be 0 only, no? Right? So if f of a is equals to f of b is given, that means f dash c would be equals to 0 only. From here, what you can conclude? F dash c is equals to 0, and it is pretty obvious, because if a and b are same, if a and b are having the same value, that means the line that you are going to draw, that will be parallel to x-axis, and then you need to take a point c such that differentiation would come out to be equals to the slope of this line, which is equals to c only. So f dash c equals to 0, that we need to do. So f dash c, what will be my f dash c? So 5x to the power 4 minus 44x to the power 3 plus 37 into 3. Okay, plus 37 into 3, which will be 111 x square minus 72x equals to 0. So here I will take x as common. Inside what I will be getting? 5x cube minus 44x square plus 111x minus 72. Now hit and trial I need to go. So if I put x equals to 1 here, I will get to know that 111156. So yeah, so x equals to 1 is one of the factors. So when I factorize it, I go to know that x into x minus 1, then inside I will get x minus 3 and I will get x minus 4.8. So when I factorize this, these are the values I am getting. Okay, so factorization is a bit difficult here. So in the examination, these kind of complex equation will not be asked. Here I want to deliver some concept, that's why I made the question very complex. But in the examination, easy equations would be asked. Okay, so when I factorize this, then this will be the factorization. Is that understandable to you? So sir, from here the answer is coming out to be 0, 1. In place of x we need to put c actually. In place of x we need to put c. So from in the end I am putting the value c here. Okay, in place of x we are supposed to put c, no, because we are supposed to find out the value of c. Right? So value of c is coming out to be 0134.8. So c equals to 0134.8, and blindly you will say that sir A, B, C, D is the answer. Wrong. This is wrong. Why is that so? Because I told you C should belong to what? C should belong to open interval 0, 4. That means C has to be between 0, 4. Always remember open interval, always remember open interval. What does that mean? This 0 will not be accepted. This 4.8 will not be accepted. Only these two values will be accepted. That means C can be only 1 and 3. That's the answer. Value of C could be only two possible values are there, which is 1 and 3. So these will not be accepted. So always take care one thing, that whenever you solve it, always we need to take care that what all points are lying in the boundary. Is that understandable to you? So shall we draw the graph of fx? So whatever the fx was given, this fx was given. This was whatever the fx was given. I am just putting that yes, fx was given. Now when I differentiated f dash x, what value I was getting? This is the value I was getting, which was x into x minus 1, x into x minus 1 multiply with the x minus 3 multiply with x minus 4.8. So how will I draw the graph? So this is how you will draw the graph. I hope you remember it, because our next topic is completely related with the graphs only. So please do revise your basics. Whatever the basics that we have studied, that we need to revise. Basic mathematical foundation. Okay. So we spent there 7 to 8 hours. So that 7 to 8 hours you need to revise. So that this is how the graph would look like. So sir, graph would be increasing, then sir decreasing, then again increasing sir, then till this point again, then decreasing, and then sir again it will increase. So this will be the nature of the graph sir. In a rough manner, if I draw, what I can draw. Sir, at x equals to 0, the value is 0, no? At x equals to 0, sir, the value is 0 only. So before this, the graph will increase. Sir, before this, for x less than 0, the graph will be increasing. So the graph will be increasing in this manner, sir. And after that, sir, it will decrease only. So after that, it will decrease. Till what point? Till x equals to 1. Till x equals to 1. 1. Then this point is 3. In between, point 4 will also come. Why I am putting point 4? Because point 4 is also my matter of concern. Sir, why it is a matter of concern for you? Because at point 4, I need to comment. And then sir, 4.8 as well. Okay. So this is how the graph would go. Then it will be increasing. Now till what point it will increase, that I don't know. At x equals to 2, what will be the value, that I don't know. But let's take up a rough graph, that this is how it will be increasing. Okay, some value it will attain, then here it will become 0, then it will become a minimum value, and this is how the graph would go. Look, here there is 0 slope, 0 slope. Here there is 0 slope, 0 slope. Here there is 0 slope, 0 slope. Here also there is 0 slope, 0 slope. F of 0 value is 0 only. This is the graph of fx we have drawn, fx versus x. So f of 0 value is 0, f of 4 value is 0 only. What we are supposed to do, we are supposed to join these 2 points. We are supposed to join these 2 points, and then we are supposed to find out the slope of this line. What will be the slope of this line? The slope of this line will be 0 only. That means now we need to find out 2 points which are parallel to this line. What will be those 2 points? So this will be one of the point, and this is one of the point. So here you can see that x equals to 3 we are getting, and x equals to 1 we are getting. Someone would say that sir, at x equals to 0 as well we are getting the 0 slope, but it is not included. Here also we are getting the 0 slope, but it is not included, right? They will also have the 0 slope, they will also have the 0 slope. Here also the slope is 0, here also the slope is 0, here also the slope is 0, here also the slope is 0. But we need to comment between 0 to 4 only, and between 0 to 4, not at the boundary point as well. So even if the answer was 4, then also I would not have taken it. I will only take the in between points. Those points will be 1 and 3. So only 1 and 3 will be accepted. By the graph as well it is clear, but in the examination you should not be drawing the graph. It is not required. So this is how the graph would go, and these are the values. Is that completely understandable? Okay. So this time there are 2 points which are giving me 0 slope. So multiple points could be there. Basically, let's just say this is A, this is B. So multiple points could be there like that. Like if I join these 2 points, then this is the slope. Here the slope is also 0. Here also the slope is same. Here also slope is same. Here also slope is same. Here also slope is same. So multiple points could be there. This time we got 2 points. But always take care one thing. The points should be between the given scenario. What is that given scenario? The given scenario is that the point should be there. This point C should be there between A and B. Always remember that. Okay. Always remember that. Let's keep it here. Let's keep it as it is. Let's make it look a bit better. Okay, so this is how you will remember that C has to be between A to B, not even at the boundary, it should be in between. Understandable? So this what is the interesting thing you find out here? That sir, here f of B was equals to f of A. This is the interesting thing that we have find out. So let's try making something more conclusive. What I am trying to do is that this time I am going to take 2 points, point A, x equals to A. I am going to take 2 points, x equals to A and x equals to B. 2 points I am going to take, x equals to A and x equals to B. So at x equals to A, what is the value I am expecting? F of A. And at x equals to B, what is the value I am expecting? F of B. And both values I am same I am taking. This is the graph of fx I am drawing. So f of A equals to f of B. F of A equals to f of B. So between A to B, I am drawing the curve like this. Okay, so this is how I have drawn the curve. Now what I have seen is that f of A is equals to f of B. Now if I join these 2 points, if I join A and B, then what is the slope I will be getting? If I join A and B, what is the slope I will be getting? So the slope of this line is nothing but 0. What is the slope of this line? Slope here is 0. How it is 0? Because sir, it is parallel to x-axis. So the slope is 0. Then I need to find out the point C. Then I need to find out the point C such that it belongs to A to B, in between A to B, and its slope will be equals to 0 only. That means I need to find out all these points. What will be the slope here? Slope will be 0. Slope will be 0. Slope will be 0 here. Slope will be 0 here. Slope will be 0 here. So are you able to understand this point? What Lagrange's mean value theorem used to say? That f dash c is equals to f of b minus f of a divided by b minus a. Now I am saying that if f of b equals to f of a, then what will be the scenario? F dash c should be equals to 0. That's it. So from here you can find out the value of c. From where this condition came? This condition came with the two condition. What was the condition? The condition was that fx should be continuous for all x belonging to a to b, and fx should be differentiable for all x belonging to open interval a to b. Then this condition would come, and this c has to be belonging to in between a to b only. Understandable? All good, all fine. Now this particular theorem is known as Rolle's theorem. So Rolle's theorem is nothing but it is LMVT only, Lagrange's mean value theorem only. They have just given one more condition, that is f of a equals to f of b. So if they are saying Rolle's theorem, then by default you would know that, sir, if a Rolle's theorem they are saying, that means f of a has to be equals to f of b. That means these 2 points that they have mentioned, I will find out the value of f of minus 3. What value I am getting? If I put minus 3 here, the value I am getting is 0. And if I find out f of 0, then I am getting value 0 only. That means f of minus 3 equals to f of 0. Is this function continuous and differentiable? Is this continuous? Yes. Is this continuous? Yes. Is this continuous? Yes. That means the whole function will be continuous only. E to the power y equals to x, is it continuous? Yes. X plus 3, is it continuous? Yes. E to the power minus x by 2, is it continuous? Yes. All are continuous. Multiplication of all of them will be continuous only, and surely they are differentiable as well, because there will not be any sharp transition. You cannot see any sharp transition. Sharp transition would occur if there is mod of x there, right? Or the function would break if there is a greatest integer function. So all this kind of scenario is not there. So no sharp transition is there. What does that mean? It will be continuous and differentiable as well. So no doubt about that differentiability, no doubt about the continuous part. So yes, it is continuous and differentiable. Continuous for all x belonging to minus 3 comma 0, and differentiable for all x belonging to open interval minus 3 comma 0. So everything is satisfied. Yes, Rolle's theorem can be applied. Rolle's theorem can be applied. So what Rolle's theorem would say, that differentiate the function, then put x equals to c, that should be equals to 0. So can I differentiate this function? Yes, sir. What I will do is that, let's write down fx here. What is fx? I will put fx as this x I am taking inside, so x square plus 3x, x square plus 3x e to the power minus x by 2, minus x by 2. So can I differentiate the function? Absolutely, sir. So first, as it is, differentiation of second plus second as it is, differentiation of first, right? E to the power minus x by 2 will be differentiated as e to the power minus x by 2 multiply with minus 1 by 2. This is the scenario you will be getting. Okay, so e to the power minus x by 2 you will take common. So from here what I can sense is that I will take e to the power minus x by 2 as common. 2x plus 3 minus x square by 2 minus 3x by 2. Right? 2x plus 3 minus x square by 2 minus 3x by 2. So what you will be getting? E to the power minus x by 2 minus x square by 2, then plus x by 2 plus 3 minus x square by 2, 2x minus 3 by 2 will be plus x by 2 plus 3. So minus sign you can take outside. What you will be getting? X square, and divided by 2 also I am taking outside. So x square minus x plus 6. So this is the scenario we are getting. Okay. So the scenario we are getting is e to the power minus c by 2 divided by 2 x square minus c square minus, actually in place of x we are putting c. So c square minus c plus 6. Okay, are we doing it correctly? Or there is a problem of plus minus? Yeah, minus 6 will be there, no? Here there will be minus 6. This is what I was thinking. Here there will be minus 6. Right? So 3 comma 2. If I put 2 here, 3 comma minus 2 or what? E to the power minus c by 2 divided by 2. So e square minus 3c plus c minus 6. sorry, c square minus 3c plus 2c minus 6 equals to 0. Okay, so e to the power minus c by 2 divided by 2, then c plus 2 multiply with c minus 3 equals to 0. Now this part will always be positive, no? Like this part can never be 0. What I mean to say is that e to the power minus c by 2 divided by 2 can never be equals to 0. It can be 0 only at, it would be 0 only at c tending to infinity. When c is infinity, the time when c is infinity, e to the power infinity, e to the power minus infinity, what is that? 0 only. So when c is infinity, at that time only it would be 0. So forget about this part. From here what you are getting, c equals to minus 2 and 3. Minus 2 and 3. So will that be answer? Sir, minus 2 and 3. Both will be the answer. No, this 3 will not be the answer. No, this will not be the answer. Why is that so? Because sir, minus 2 belongs to the interval minus 3 comma 0. Yes, but 3 does not belong to this interval. That means only answer is c equals to minus 2. This is the only answer. In the examination, they will frame it as a MSQ and you will click on 2 answers. But only one answer would be there. Okay, only one answer would be there, that is minus 2. So is that understandable to you? Have you verified the Rolle's theorem or not? Absolutely, sir. We have completely verified the Rolle's theorem. Shall we try drawing the graph? What I am saying is that, shall we try drawing this graph? So we can try it. Okay. What we are going to do is that we are going to try drawing this graph. Do we have a page? Yes, we have a page. I am trying to draw the answer is done. Okay, our job is done. But let's try drawing the graph. The function is given as x into x plus 3, x into x plus 3 e to the power minus x by 2. So whenever exponential is given, whenever exponential is given, you should always check the value at infinity and minus infinity first. So can I check the value at f of infinity? So that will be infinity into infinity, infinity into infinity, multiply with e to the power minus infinity by 2. Right? What will happen? This is becoming this is becoming infinite into 0 form. So you will have to take the limit. Basically, it will become infinite into 0 form. No, so infinite into infinite is infinite only. E to the power minus infinity by 2, that is becoming 0. So it is becoming infinite into 0 form. That means you will have to take the limit now. So that limit and all we will ignore. So let's not do it. As of now, let's get started. What we used to do is that we used to differentiate the function. So when we differentiate the function, what we are getting? When I differentiated it, very carefully I can see that I am getting e to the power minus x by 2 divided by 2. E to the power minus x by 2 divided by 2. Then multiply with x plus 2, x minus 3. Say yes or no? X plus 2, x minus 3. This is what we are getting. Okay. So if I know that how many roots I will be getting from here. So this will be root at infinity. I don't care about it. So from here, sir, I will be getting 2 roots, which is minus 2 and 3. So if I draw it on the number line, minus 2 and 3. Minus 2 and 3. Tell me very carefully, if x is greater than 3. If x is greater than 3, then the differentiation will be positive or negative? This much part will be positive. E to the power minus x by 2 is always positive. Do you know the graph of e to the power minus x by 2? This is the graph of e to the power minus x by 2. At infinity, 0 value, at minus infinity, infinite value. So this is the graph of e to the power minus x by 2. So this is always positive because the value is always in the positive axis. So this will be always positive. If x is greater than 3, then this will be positive. This will also be positive. So this whole particular scenario is always positive. But there is a negative sign here. No. So this will be negative, this will be positive, and this will be negative. Is that understandable to you? Usually people ignore this negative sign. Our scenario is that this is our f dash x and we will build up a with that, sir, okay, 3, just as I will put plus here. No, not plus. You need to check this sign as well. Is that clear to you? So when we differentiated e to the power minus x by 2 to x plus 3 and then minus x square plus 3x as it is, and e to the power minus x by 2, 1 by 2 we took, then e to the power minus x by 2 we took common, and from here we go to know that, yes sir, we are getting one negative sign outside as well. What we are getting one negative side outside as well. Okay, so that negative sign is also our matter of concern. So what will happen is that the graph is first decreasing, then it will increase. First it is decreasing, then at this point it will start increasing, and then it's at this point it will start decreasing. Okay, so this is how the graph would go. So can I find out the value of f of minus 2? What will be the value of f of minus 2? F of minus 2 will be nothing but, if I put minus 2 here, so that will be nothing but, if I put minus 2 here, so this will be 1 and e to the power 2 by 2. So answer is coming out to be minus 2e. And what will be the value of f of 3? f of 3 if I put, so this value will come out to be 3 into 3 plus 3 is 6, 18 e to the power minus 3 by 2. And when I put minus 2, it came out to be minus 2 e to the power 1. And when I put 3, it came out to be 18 e to the power minus 3 by 2. So this is a positive value, no? E to the power minus 3 by 2 is always positive, 18 is also positive. So this is a positive value and this is a negative value. So if I draw the graph, and now I already know from where the graph is coming. I don't need to find out the limit. I already know from where the graph is coming. And one more value, let's just find out the value of f of 0. So f of 0 is 0 only. F of 0 is 0 only. And along with that, f of minus 3 also I know that is 0. So let's draw some points. Some values I already know. Let's just say this is x equals to minus 3. This is x equals to minus 2. This is x equals to 0. This is x equals to 3. Okay, so starting from infinity, f of minus 3 is 0, then the value I will get is minus 2e, then the graph will start rising. The graph will rise till f of 3 till this point, okay, and after that it will decrease in this manner. After that it will decrease in this manner. So this is how my graph would be going. This is the graph of f of x. So any graph I can draw if I have good enough concept. Okay, any graph I can draw. Now if I ask you one thing, okay, all these values you already knew. Using these values, now I am asking you one thing, limit x tending to infinity, x multiply x plus 3 e to the power minus x by 2. What will be the answer here? Sir, you can solve the limit on your own. Answer will come out to be, sir, minus infinity for sure. You can do it on your own. Okay, and limit x tending to minus infinity, x into x plus 3 e to the power minus x by 2. This answer will come out to be infinity only. Okay, you can check on your own, because here the value is infinity and here the value is going to minus infinity. So is the graph absolutely fine? So yes, sir, completely absolutely fine. Now in which points they wanted us to analyze? They wanted us to analyze between minus 3 to 0, between minus 3 to 0, between minus 3 to 0. So what is that point where if you join minus 3 to 0, if you join minus 3 to 0, then sir, this is the scenario we are getting. This is the slope we are getting. What is the slope here? The slope here is 0. I need to find out the point in between where the slope is 0 only. So that is this point. So if I had just started drawing the graph only, no, then also I would get to know that my answer will come out to be only minus 2. So at this point, my slope is nothing but 0. Here the slope is 0. Here also the slope was 0 only. So this is what I could have done. So what will be the option? Only minus 2. Someone would say that, sir, at 3 as well the slope is 0. At x equals to 3 as well, sir, here as well the slope is 0. But it is not belonging to this interval. They are asking about only the interval between 0 to 3. So no matter wherever the slope is 0, we don't care about it. We only care about one interval, and that interval is minus 3 to 0. Is that completely understandable to you? Is the drawing graph is also understandable to you? Why I am drawing these graphs? Because in the next lecture, the same thing we are going to do. Only we are going to draw the graph. This point will be known as local minima. This point will be known as local maxima. This will be absolute maxima. This will be absolute minima. That's it. Next chapter is completed. Okay. Next chapter will be of 6 to 7 hours. We will do the problem solving, but concept is minimum there. Okay. Minimum concept is there. Everything we have covered in the basics. First, I thought that in the basics only I will teach that particular chapter, because then it will become a lot of conceptual things. You might feel like that, sir, okay, there are a lot of things. So that's why I dropped down. I only asked you to draw the graph and some basics I taught, and then in the next lecture you would see that we will start application of derivative, and you will feel that, sir, I already know everything. And that is considered as one of the finest chapter of mathematics. Even in JEE examination as well, that is considered as one of the finest chapter, but you will be able to solve the problems. Even JEE advanced problem, toughest JEE advanced problem, you will be able to solve very, very, very easily. Okay, and we are going to solve as well. Understandable? Job done? So yes, this was the graph. This is the scenario that we have seen. And can you find out these limits? Shall I give you some more intuition? E to the power minus x by 2, limit x tending to infinity. X plus 3. X square plus 3x. Although you can find out the limit, but I am thinking if there is any easy way. E to the power minus x by 2. The graph would go like this. At x tending to infinity. Other easy way I am not able to find out. So you will have to apply that L'Hopital rule only. How will you do it? How will you find out this limit? I was just thinking that can I give some intuition, but no, mathematics only we will have to apply. Basically, if I am asking you this limit, you need to find out without drawing the graph. Without drawing the graph, you need to find out this limit, x into x plus 3 e to the power minus x by 2. So what you will do is that, sir, you will directly put infinity here. So infinite into infinite plus 3 e to the power minus infinite by 2. So what it will become? Infinite into 0. So this will become infinity into 0 form. That means, sir, there is some problem. So what I will do is that I will make it infinite by infinite form. How will I make it? X into x plus 3 divided by e to the power x by 2. Okay, so let's make it x square plus 3x. X square plus 3x. Okay, so limit x tending to infinity, this will become 2x plus 3 e to the power x by 2 multiply with x tending to e to the power multiply with 1 by 2. Again, if I put infinity by infinity, it is becoming infinity by infinity only. So let's differentiate once more. X tending to infinity, 2 divided by e to the power x by 2 and 1 by 4. Value is coming out to be 0. Okay, now if I put x tending to infinity here, what we are getting? E to the power infinite by 2, 1 by 4. So what is the value? 2 divided by e to the power infinity. So what is the answer we are getting? 0. So this graph was wrong. Okay, I tried being smart. Look, the value will decrease. No, so who told that value will go to infinity? The value can go to 0 as well. When we actually find out the limit, the value is actually going to 0. Okay, that was a blunder from my end. That was absolutely baseless things from my end. Okay, the limit, when you find out, it is coming out to be 0. No, like I know that after that the graph would decrease, but who told the graph will go to infinity or minus infinity? Who told that? Right? So that was absolutely baseless thing from my side, like blunder from my side. This kind of conceptual error should not have happened, but I did it. Okay, so that was a blunder from my end. That was very bad mistake. If the graph is decreasing, who told that it will go to minus infinity? It can go to 0 only as well. And yes, you can see here, infinite into 0 form was there. I tried doing in this manner. Infinite by infinite form I am getting. Infinite by infinite form, 2x plus 3, then 1 by 2, then again 2 divided by e to the power x by 2. Value is coming out to be 0. So yes, it is ending at 0 only. Now who knows this value was my plus infinity or not? Basically, it is supposed that the value will rise, but from where it will rise? It can rise from here as well. It can rise from here as well. From anywhere it can rise. No, so this is also baseless thing from my side. I should also check the limit here. So limit x tending to minus infinity. Okay, x into x plus 3 e to the power minus x by 2. Right, so this will become minus infinity. If I directly put the value minus infinity into minus infinity only, and this will become e to the power infinity by 2. Simply it will become infinite into infinite. Okay, here it is plus infinity only. What I mean to say is that simply put minus infinity here. If you are putting minus infinity here, what will happen? This will become minus infinity. This will become minus infinity plus 3, right? Minus infinity plus 3, and this will become in place of x you need to put minus infinity. So this will become plus infinity, right? So what you are getting here? Infinite multiply with infinite, infinite multiply with infinite, and this is also e to the power infinity by 2. That is also infinity. So infinite into infinite into infinite will be infinity only. So this value is correct. So it will start from infinity, then goes down like this, and then goes to 0. So this is the error that I did. Big blunder from my end. Blindly I said that it will go to 0, which was very baseless. Sorry, blindly I said that it will go to minus infinity. That was a baseless thing from my end. It is going towards 0 only. So in the examination, who knows, someone ask that what is the minimum value of fx? One of those option will be mentioned minus infinity. I will click on minus infinity and I will lose 2 marks. Minimum value of fx is here f of minus 2. What is the value of f of minus 2? That is minus 2e. So this is the minimum possible value of fx. What I mean to say is that what is the minimum value of fx? What is the minimum value of fx? That is equals to f of minus 2. You can see f of minus 2 because here it is ending at 0, right? So that value is nothing but f of minus 2, which is equals to nothing but minus 2e. So that's the minimum value. And if someone would have asked what is the maximum value of fx, so maximum value of fx, you know that already it is infinity. Okay. So I said that this point is local minima, but this is not actually local minima. This is global minima because this is the absolute minimum value. The graph fx is not attaining any value lesser than this. This is the absolute minimum value that we are getting. That value is minus 2e. Below this we are not getting any value. Here I did that it will be going towards minus infinity. That was an absolute baseless thing from my end. Okay, so these kind of blunder as an educator should not have happened, but I am sorry for that. But yeah, conceptual error you will not find in our lectures. I again, like when I was doing this analysis, I thought that something wrong I am doing. That's why I went with the limit. okay, because I was trying to think intuitively. What I was trying to think, that this particular graph at infinity will go to 0, right, and this particular graph will be very high. Are you able to understand this point? E to the power minus x by 2, the graph will go like this, no? So this is going to 0, and x square plus 3x, I don't know what will be the graph, but I know that the graph of x will be like this and the graph of x plus 3 will be like this. So multiplication of both of them will be going towards a very high value. I don't know what will be the nature of the graph, but it will be like some very high value here. So very high value and very low value, I don't think the value should be minus infinity. This is what I was thinking in my brain. Then I thought that let's try doing the calculation. I was just thinking intuitively that how the value can go to minus infinity. It's not looking like that. Here the value is very low, here the value is very large. The value going to minus infinity, it is not clicking to me. So that's why intuitions are important, no? Just as I wrote down the result, that was a blunder from my end. I wrote down the result as minus infinity, but still, I had good enough intuition. I thought that, okay, this value is going towards infinity, this is going towards 0. How the value can come out to be minus infinity? Which is not possible, right? So that's why I thought of this and I got to know that, yes, there was some blunder and we avoided the mistake. But here, sir, this is minus infinity, this will become plus infinity only. So they are going towards plus infinity, this is also going towards plus infinity only. Infinity into infinity is infinity. So yes, this is infinity, that is correct. So graph would go somewhat like this. Understandable? Okay, so it was a good question. We have solved the question of next lecture as well, right? This question we have solved, which is of next lecture. In the next lecture, we are going to study application of derivative, but in the next lecture as well, this kind of question could have been asked. What is the absolute minimum value? That is nothing but minus 2e. Minus 2e. Okay, let's go to the next question. So this question has been asked in JEE Advanced only. Okay, you need to find out the value of alpha for which Rolle's theorems can be applied. Rolle's theorem can be applied. You don't need to apply the Rolle's theorem. This time they are asking the condition of Rolle's theorem. So what is the condition of Rolle's theorem? Condition of Rolle's theorem is that, sir, first one, continuous for all x belonging to 0, 1. Second, differentiability for all x belonging to open interval 0, 1. And sir, next one is f of 0 should be equals to f of 1. Okay, so first let's check the continuity. Where will I check the continuity? Will I check the continuity at 1? If this question was given and I asked you to calculate the continuity, what you will do? Will you talk about x equals to 1? No. I told you continuity is always checked the point where the definition is changing. So definition is changing at x equals to 0. So now if it is continuous, what does that mean? F of 0 should be equals to f of 0 plus. What is the value of f of 0? F of 0 is 0 only. F of 0 is 0 only. So from here I can say that f of 0 plus should be equals to 0. Now what is the value of f of 0 plus? F of 0 plus. So f of 0 plus is nothing but 0 plus into alpha multiply with ln 0 plus. So let's keep it as 0 plus into alpha only, but ln 0 plus will be what? Minus infinity. Now why I kept this as 0 plus into 0 plus to the power alpha only? Like what is 0 plus? 0 plus is 0.0000001, right? This is your 0 plus to the power alpha minus infinity. If you notice one thing, if alpha is greater than 0 or if alpha is less than 0, what I am saying is that my f of 0 plus has come out to be some expression which is 0.0001 to the power alpha minus infinity. So if alpha is greater than 0, then what will happen? If alpha is greater than 0, then this power will be, let's just say alpha is greater than 0, so I am taking alpha equals to 1. So what will be f of 0 plus? That will be 0.00001 to the power 1 multiply with minus alpha. Right, so this is very low value to the power 1. So approximately it is 0 only, no? So 0 to the power 1 will be 0 only. So this will become 0 into minus infinity. So this is an indeterminate form. But what if alpha is less than 0? If alpha is less than 0, then what will be the value of f of 0 plus? So that will be 0.000001. Alpha is less than 0. Let's take alpha equals to minus 1. Multiply with minus infinity. So it is nearly 0 only. 0 to the power minus 1. This minus infinity as it is 0 to the power minus 1. That can be written as 1 by 0. So this will be divided by 0. So it is coming infinite. 1 by 0 is nothing but infinity only. So it is infinite by 0 form, or you can say infinite into infinite, so it is becoming infinity only. What I mean to say is that if alpha is less than 0, if alpha is less than 0, then f of 0 plus is coming out to be nothing but minus infinity. That means f of 0 plus can never be equal to f of 0. What does that mean? Rolle's theorem cannot be applied. Rolle's theorem cannot be applied. Cannot be applied. Is that understandable to you? Because this is the some value you are getting, no? So here there is no meaning of taking the limit. Here you have got the value that sir, if alpha is less than 0, that means this will be sir 0 plus to the power minus 1, minus 2, or minus 0.001. So it will go in the denominator. So very less value, 0 to the power infinity, sorry, 0 to the power anything is nothing but 0 to the power anything is nothing but sir 0 only. So minus infinity divided by 0, that will become minus infinity only. That means limit will not even exist. F of 0 plus will not be equal to f of 0. This will never be able to, this will never be possible. What does that mean? Rolle's theorem cannot be applied. That means these options are not possible. Option A and option B. Minus 1 and minus 1 by 2 is not possible. Now sir, if alpha is greater than 0, then what will happen? F of 0 plus will be equal to f of 0. No, no one knows. If alpha is greater than 0, then what will be the condition? Sir, if alpha is greater than 0, then I am getting 0 into minus infinity, which is the indeterminate form. So if I am getting this indeterminate form, then sir, yes, now what I need to do is that I need to apply L'Hopital rule. Not L'Hopital directly. What I will do is that I will adjust it. I will do ln x divided by x to the power minus alpha. So what I am saying is that if alpha is greater than 0, so what is your fx? Fx they have given is ln x multiply with x to the power alpha. What I am doing is that I am writing it down as ln x divided by x to the power minus alpha, because what I need to do is that I need to find out limit x tending to 0 plus ln x divided by x to the power minus alpha. I can see that sir, this will become infinite by infinite form only, because alpha is greater than 0. Alpha is greater than 0, you can take any value. Let's take alpha as 1. So what it will become? 0 plus to the power minus 1, that will become infinity. So it will become infinite by infinite form. So what I can do now, I can apply L'Hopital rule. So limit x tending to 0 plus 1 by x minus alpha x to the power minus alpha minus 1. So limit x tending to 0 plus 1 by x minus alpha x to the power minus alpha divided by x. Limit x tending to 0 plus 1 divided by, this is the scenario. Now if you put 0 plus here, what is the answer you are getting? 1 divided by minus alpha. 0 plus means 0.00001 to the power minus alpha. If alpha is greater than 0, 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 then 0 to the power, let's just say minus 3 you are putting. So what will be 0 to the power minus 3? That will be equal to sir 1 by 0 to the power 3. So scenario is 1 upon minus alpha, which will be a constant value that we are taking as 3. So minus 3, then 0 to the power minus 3. This is the scenario. Now 0 to the power minus 3 can go upward. It will become 0 to the power 3 divided by minus 3. What will be the answer you will be getting? 0 divided by minus 3. Answer will be 0 only. So are you able to understand this point? So if alpha is greater than 0, then answer would be 0 only. So alpha greater than 0 will be accepted. What I mean to say is that what we have understood, if alpha is greater than 0, then we are getting this condition. F of 0 plus is equals to f of 0. There you go. So what is required for us? Alpha greater than 0 is required. That means this value will be accepted and this value will be accepted. Now someone will say that sir, you did not check these values. We can check these values. What is the value of f of 0 given here? F of 0 is given as 0 only. You can see f of 0 is given as 0 only. What is the value of f of 1? So that will be nothing but 1 to the power alpha ln 1. Alpha is some positive finite value. Ln 1 is 0. So this will become 0 only. So yes, f of 0 is also equals to f of 1. F of 0 is also equals to f of 1. Now you take any value of alpha, any positive value of alpha you take and draw this graph x into ln x. In the next lecture we are going to do it as well. You will find out that it will be differentiable as well. Okay, it will be differentiable in 0 to 1. It will be differentiable everywhere. It will be everywhere differentiable. So this condition will also be followed. This condition will also be followed. This condition will also be followed for the positive value of alpha. And we will do it as well. For the positive value of alpha also we will do. For the negative value of alpha also we will do. Basically in the next lecture we will draw the graph of x ln x as well. And we will draw the graph of ln x by x as well. If you took alpha equals to minus 1, then this is the value you will be getting ln x by x. If you took alpha equals to 1, then this is the value you will be getting. So in the next lecture, we will draw the graph. Don't worry about it. Okay, we will draw these graphs and you will get to know that, yes sir, these graphs are differentiable. Understandable? All good? All fine? So how we checked? Continuity is the, like, most probably in the examination, using only the continuity, you will be able to get the answer. So f of 0 plus should be equals to f of 0. So that we checked and we go to know that, yes sir, f of 0 plus is coming out to be equals to f of 0 for alpha greater than 0. Because sir, if alpha is less than 0, then there is a problem. What is the problem? Then it is becoming infinite into infinite form. Because if it is less than 0, then if you put 0 here, what will be the scenario? 0 to the power some value that is equals to 0 only. So minus infinite by 0 form you will be getting, that is equals to minus infinity only. It is not an indeterminate form, right? 1 by 0 could be written as infinity, so it is not an indeterminate form. But sir, if alpha is less than 0, if alpha is if alpha is greater than 0, then if we find out the limit, we go to know that it is coming out to be nothing but equals to 0 only. This limit is coming out to be nothing but equals to 0 only. And how did we find out the limit? We made it as infinite by infinite form, because this is minus infinity, 0 plus to the power minus alpha, that is also infinity only. So infinite by infinite form, I can apply the L'Hopital rule. I go to know that, yes, this is what I am getting. Then I simply put a 0 to the power alpha here, 0 to the power minus alpha here. I go to know that it is coming out to be 0 only. Understandable? So alpha greater than 0 is the required condition. Not a very straightforward question. These kind of questions, GATE examination will surely start asking. Okay. Now, if you see, they are every year they are increasing the level of engineering mathematics. Every year they are increasing the level. So if they increase the level, then these kind of question would come up. Okay. This is the last question. Again, J advanced problem. Do it on your own. It is a MCQ only. Okay, MCQ only. So which of them will not have the Lagrange's mean value theorem between 0 to 1? Not applicable. Not applicable. Between 0 to 1. What is the condition of Lagrange's mean value theorem? Only two conditions are there, sir. Continuous for all x belonging to 0 to 1 and differentiable for all x belonging to 0, 1. Can you draw this graph? Option D. Let's get started with option D. Option D. Mode of x. I am drawing the graph of mode of x. So this will be the graph of mode of x. Mode of x is always continuous, right? Nowhere the graph is breaking, always continuous. What about the differentiability? Someone who said, sir, it is not differentiable at x equals to 0. Do I care about it? No. Open interval. I don't care about it. Even if there was closed interval, then also I would say that it is differentiable. Why is that so? Because f dash of 0 plus is finite, which is some value which is equals to m equals to 1. Right? Even if it was closed interval, then also it was correct that it is differentiable. Now here there is open interval. Nowhere there is a sudden change. I am caring about only 0 to 1. No sudden change is there. Differentiable as well, continuous as well. Job done. Yes, this will be following LMVT. That means this will follow LMVT. Will follow LMVT. LMVT can be applied. So this will not be the answer because they are asking where it is not applicable. What about this C? C option. C option is given as x into mode of x. We are caring about only 0 to 1. In 0 to 1, if x belongs to 0 to 1, how this will be opened? This will be opened as positive x only. Or basically, let's define it. No, I can define it as well. I can draw the complete graph. How I can draw the complete graph? How it will be opened? Sir, if x is greater than 0, then it will be x square. If x is less than 0, then it will become minus x square. So can you draw the graph? Absolutely, sir. X square and minus x square. Is there any sharp change? This is a smooth change only, okay? This is a smooth change. This is a smooth change only. What is a sharp change? Sharp change is like this, right? Or somewhat like this. This is again smooth. The curve is smooth. This is a smooth change. This is also smooth. This is also smooth. This is also smooth. Right? These are smooth change only. So this is the graph of fx. And even we don't need to care about it. No, we don't need to care about the value at x equals to 0. We don't need to care about the differentiation. We only need to care about all the differentiation between 0 to 1. And I can surely see that yes, it is continuous and differentiable. That means yes, it will be following. Everywhere the graph is continuous and job done. Okay, can you draw the graph of B? Yes sir, you have told me to draw the graph of sin x by x as well. I can easily draw the graph of sin x by x, and they have also given that at x equals to 0 the value is 1. What they have given? At x equals to 0 the value is 1. So this they have given, and I know the graph of sin x by x, sir, it will go like this. Everywhere it is continuous as well, and everywhere it is differentiable as well. So no doubt about anything else. Okay, yes sir, continuous and differentiable. That means this will also follow LMVT, follow LMVT. This will also follow LMVT, follow LMVT. So yes sir, this is also following. That means in the examination, without even doing the calculation, I can click on this option, right? But you can do the calculation on your own. What you need to do is that you can check the continuity and differentiability both. Okay, where the definition is changing, the definition is changing at 1 by 2. So let's check the continuity at 1 by 2. In option A, f of 1 by 2 plus, what that would be equivalent to? F of 1 by 2 plus 1 by 2 plus. So here if you put 1 by 2, what answer you will be getting? 0. And what will be the value of f of 1 by 2 minus? F of 1 by 2 minus, that means here it will be followed, that is also 0. And what is the value of f of 1 by 2? F of 1 by 2. So put 1 by 2 here, this will be again 0. What does that mean? Continuous, yes, continuous is there. Continuity is there. No doubt about the continuity. But what about the differentiability? So if fx is given, can you find out the f dash x? Fx is defined as 1 by 2 minus x, right? 1 by 2 minus x, and here 1 by 2 minus x whole square. For x less than 1 by 2, x less than 1 by 2, and here for x greater than or equals to 1 by 2, greater than or equals to 1 by 2. Can you find out f dash x? Absolutely sir. So f dash x will be minus 1 and 2, 1 by 2 minus x, and then minus x will have the differentiation of minus 1 as well. So this minus 1 goes inside, so it will become x minus 1 by 2, x minus 1 by 2. Minus 1 goes inside, it will become x minus 1 by 2. So x less than 1 by 2, x greater than or equals to 1 by 2. Okay, so f dash 1 by 2 minus, what is the value? F dash 1 by 2 minus is minus 1, and f dash 1 by 2 plus, what is the value? Here if you put 1 by 2, this answer is 0. So they are not same, that means it is not differentiable, non differentiable. What does that mean? Option A is correct. So this particular thing is non-differentiable at 1 by 2, non-differentiable at x equals to 1 by 2, where 1 by 2 is belonging to 0 to 1. 1 by 2 is belonging to 0 to 1. Okay, 1 by 2 is belonging to 0 to 1. So here it is non-differentiable. That means yes sir, this answer is also, this answer only is correct. Rest all are continuous as well and differentiable as well. Understandable? All good, all fine. So option A is correct. So yeah, here our LMVT is ended. Okay, Lagrange's mean value theorem is ended here. All good, all fine. So this was a good graph here that we have understood. So x into ln x will also be a good graph. X into ln x or ln x by x, they will also be a good graph. But in the next lecture, we are going to see them. Okay. So here our limit, continuity and differentiability is ended. Next, what we are going to study? We are going to study applications of derivative, maxima, minima, saddle point, inflection point. People usually think that saddle point and inflection point are same, but no, they are not same. What is the meaning of inflection point? All those points, very, very intuitive and very, very interesting point we are going to see in the next lecture. Okay. So let's meet on Monday. I will upload the video of application of derivative from Monday onwards. We will try to complete, I guess in 2 lectures it will be completed, or maximum it can go up to 3 lectures. And then we will study about the functions of 2 variables. So that will be somewhat around 5 hours of video, 4 hours of video, but in one video only we will cover the functions of 2 variables. So we will see the differentiation, we will understand the meaning of partial differentiation, everything we will study, and then our differential calculus will be ended. And next we will start integral calculus. Okay then, and after clearing integral calculus, we will start a probability and statistics. Okay, probability and stats we will see. So this will be the flow, but yeah, let's move to the next lecture. In the next lecture, we are going to study about applications of derivative. Thank you very much. Happy learning.